Okay, we're going to go over limits. And we have this limit question here. Is the limit of x as it approaches 2. Now, briefly looking at our equation, it looks like if we were to essentially plug in the value of 2, we have something that would be undefined, right? But we're going to simplify this equation and see where we go with it and see if the limit exists. So we're going to actually expand on top, and that will give us a quadratic, and then we're going to include the negative 16 into it and see if we can factor out something like x minus 2. So technically we should rewrite the limit over and over again. I'm going to rewrite it once and then kind of just quotation to speed us through this process. But if we were to expand this, we would end up with x squared plus 4x plus 4 minus 16. Does that make sense to you?
Mm-hmm.
Okay, good. And then on the bottom, we have our x minus 2. Okay. And then what we can actually do from there is, since we don't really want to rewrite everything, I'm just going to focus on the top, factor it, and then re-put everything in. So I'll do that in blue so that you realize I'm only working with the top right now. That's not the pen I want it, but that's okay. Okay, so now this essentially will become, and I should do it in blue so we realize it's a little separate, but x squared plus, not 8x, sorry, plus 4x, and then minus 12. Okay, and then what we want to do is factor this. So we're going to look for factors, two numbers that multiply to negative 12 and add to 4. And positive 6 and negative 2 will work.
Mm-hmm.
Does that make sense for you? Okay, so x plus 6 and x minus 2 are our options. So now what we'll do is the same idea as plugging this back in. We've kind of replaced everything. So we'll continue the question a little lower just for space, but we have the limit. Let's go back to black so we know that we're working with our limit again. Our limit of x as it approaches 2. And what we get is x plus 6 minus 2. And this is all divided by, whoops, wrong button. All divided by x minus 2, which means we can now cancel this part out. So our limit of x plus 6, our limit of x as it approaches 2, is the value of x plus 6. So we plug in our value of 2, and we find out the limit when x approaches 2 is equal to 2 plus 6, which is our value of 8. So in other words, our limit is 8. Now, one of the other ways we could kind of go about this is we could try to, and I think this will be actually the best one to look at in this case, is we could try to graph this function. You remember we did a lot of graphing in advanced functions, right? So another thing we could do is talk about some of the things with graphing. We know that our denominator will give us what type of asymptote? Do you recall?
Vertical.
Yeah, it'll give us a vertical asymptote. And do you know where it'll be?
At x equals 2.
Yeah, exactly. Since we set it equal to 0, we can't have x cannot equal to 0, therefore x cannot equal to positive 2. So we're going to have a vertical asymptote there. Quickly looking at this here, I guess I better rewrite it. I'll write it in its standard form on top. So another version of this would be x squared plus 4x minus 12 divided by x minus 2. Actually, I lied. If we're finding horizontal asymptotes, are there any horizontal asymptotes we can think of?
No.
No, I don't see any. So we have our vertical asymptote, and we know that essentially the idea is it's going to be approaching 2. So we can kind of see what values we would be coming close to at the value of 2 here, okay? So let's see if we can't do that. One of the processes we could use is, and it doesn't matter if it's in this form or the original form we started in, we can think of a number or the idea of approaching 2 from a specific direction. So say we were going to approach, find like the limit of x approaching 2 from the left, and that's how it's usually described, and the limit of x as it approaches 2 from the right. Okay, and in order to do that, think of it like we would like to use a number like 1.999, something extremely close to 2, and another number of 2.0001. Okay, we know that that'll actually not create a, it won't create a 0 on the bottom. So we can plug those values into here and kind of get an idea of which direction it's heading. Okay, another way we could do this, and will be a fast way to show our limit. Oops. Let's look up Desmos here, and our equation reads x, I guess I better look divided by x minus 2, but it's x squared. Oh no, I lied. Sorry, it's in brackets. Bracket 2 plus x, 2 plus x to the power of 2 minus 16. Okay, and what we get here is as x approaches 2, we're essentially undefined. But as we come very close to 2, we see that we're getting very, very close to the value of 8. Okay, so as long as we have a hole in the function, and then just after 2, we're just growing from 8. So it's easy to see graphically, right? And we could do that same idea when we're doing these limits here. We can almost guesstimate what would happen here. So if we were to plug those values in, like we said, and I'll try to do it by just using the values here. For instance, the limit of x when we're approaching 2 from the left. So let's work on the bottom of the equation. We're looking at a number that's less than 2. Okay, so in other words, we're going to get a very, very, very small number. It's going to be something like negative 0.00001. Okay, and it's going to be above what value here? And our value here is 2 plus 1.99999. So that's a number that's going to be like 3.999 squared and then minus 16. Okay. This value gets, oh, these are actually just going to show us, I wonder if we have a better example if we showed, we probably chose numbers that are a little almost too close because they're going to be hard to work with. This becomes a negative 0.0001, so we don't want to be rounding when we do this. Another way we could have come to the idea is, and we chose numbers that are very close, we could have actually used the idea of 1 and 3 itself also, and they would have given us a general idea. Obviously finding the limit the way we did is the best way to go about it, but starting at values like this and then trying values like 1 and then 1.5 and maybe 2.5, so getting closer and closer to our value of 2 will give us a good idea of where the limit's going to go. Now luckily in this case we're able to simplify and solve it, but you can essentially, like we had done here where I started, at least I didn't finish it, but go through that process to see what the limit is going to be. You'd get closer and closer and closer to the value of 8. Does that make sense?
Yeah.
Yeah? Okay, good.